Okay, before I go into debunking this wild and exhaustive claim of Antonio's about the shadow of the moon during the eclipse, since it's only going to take a couple of seconds to do that, I figure I add in another point here. When I was in middle school, I had a math teacher one time who told me that math is never wrong. However, the presentation of your results can make math look wrong, which is the nicest way of saying that you can have all the right numbers and still screw up how you're going to show it to people. So I'm going to tell you the riddle that he told me. And this has been told many different ways, but this is the way he told it to me. Now, just a quick warning, I am about to fool you with correct math. Every bit of math that you're about to do in your head, if you follow along, is going to be correct. However, my presentation of it is going to make it look like two different results. Ready? All right. 3 college students come into the city. There's a big rock and roll concert, and they're going to go see the concert, and they don't want to drive all the way home, so they're going to crash overnight in a hotel. So they went around town and they found themselves a cheap motel. The 3 students walked in, wanted a room for the night. The clerk said no problem, $30 for the night. The 3 students, each one of them handed over $10, and they paid for the room. The clerk takes the money, gives them their key, and off they went. Now, a couple of minutes later, the clerk realized he made a mistake because they were college students. They were supposed to get a student discount. The student discount on the room was $5. So the clerk calls over one of the housekeepers, gives the housekeeper the $5, and says, bring this up to the room with those 3 students in it. Give them this back because I overcharged them for the room. Housekeeper takes the $5 and heads on up. On the way up, the housekeeper starts to thinking, says, how am I going to divide this $5 up between the 3 students? So the housekeeper makes a decision, says, well, how about this? With that $5, I'll split it into 3 and 2. The $3, I will give $1 each back to each of the students as their student discount, and the remaining $2 I will stick in my pocket, because they're probably going to trash the room and they're most likely not going to leave a tip. So the housekeeper goes up, knocks on the door, students come to the door, and he gives over $1 to each of the students. Now, originally each one of the students paid $10 for the room, came out to $30. But now the housekeeper gave them each $1 back. So now they've only paid $9, and 9 times 3 is 27. Well, the housekeeper only kept $2, so 27 plus 2 is 29. Where's the last dollar? Now, if you take this riddle the way I told it to you, obviously it doesn't make any sense. The last dollar seems to be missing, even though every bit of math that I just told you is all correct. However, I presented it in such a way that 3 separate formulas do not yield the same result because they don't all have the exact same values. So, what does all this have to do with Antonio Subirats and Political Hillbilly and the rather exhaustive attempt at saying that the shadow of the moon should go from east to west per the globe model, but since it goes west to east, they have something to say. Antonio and Political Hillbilly got together to do a visual form of exactly what I just did to you, using the right numbers the wrong way to yield a bogus result. Watch this segment of video. This is the opener on the most recent rendition of why this is impossible and therefore it means a flat earth, whereby nobody in any of these videos goes into what is causing the eclipse. Of course not. It's just what isn't and why it shouldn't work. I shortened it just a little bit to keep to the key points.
Hey people, okay, there seems to be some confusion with astronomers, amateur astronomers, and people who like to debunk flat earthers regarding angular rate and linear rate and the motion of the moon and the earth and shadows and eclipses. So what Political Hillbilly is going to do is going to give a breakdown of what's going on for the eclipse and basically close the case on this eclipse business that has them so confused.
Now, this body that they have there, which they are calling the moon, I am not going to call the moon. The reason why I'm not going to call it the moon is because of the fact that it is not the distance or scale or size to the moon in relation to the earth when trying to describe how the shadow of the moon works at distance. Because it doesn't work like the moon, I'm not going to call it the moon. I thought about mixing the 2 names of Political Hillbilly and Antonio and calling it Polio, but I figured that wouldn't work very well. But then I found another way to mix up the names, so this celestial body I'm going to call Hillbonio.
So here's Hillbilly with a bare bones explanation. Even the lowest IQ people should be able to understand what's being displayed. Hillbilly, over to you.
Okay, All this is based off of heliocentric math, utilizing true math, utilizing 360 degrees to represent a complete circumference. So as we do that, we know that for the moon to make one complete orbit around the Earth spends 27.322 uh, days in that one complete orbit. So this is simple math. Let me go ahead and show it to you. Although Tim Osmond, I can only laugh at your lack of ability of math yesterday with Antonio. 7 minutes to come back with no answer on how many degrees that moon would orbit during the umbrum. Shame on you. You need to go back to elementary. But anyways, the way it's done is we know that we're going to make 360, or the moon's going to make 360 degrees of an orbit. We're going to multiply that by 27.322, and we know that for every 360 degrees that the moon orbited, the Earth orbited 9,835.92 degrees. For simplicity, I rounded that up to 9,836. Excuse me, heliocentrics. As we can see here, if we can zoom in on that, or if you guys can see, that does say 360 degrees. My moon, 360 degrees of orbit, or orbital rotation. Now here's the Earth's rotation. I'm at the end of it. I'm at 9,836 degrees. So this is what it looks like on a heliocentric model as we go back to the beginning of the timeline and let it play out. So as we can see, if this node point here from the Earth to the moon's core, that represents the umbrum during an eclipse.
Another thing that Hillbilly's trying to show you here, and he says it right here.
So as we can see, if this node point here from the Earth to the moon's core, that represents the umbrum during an eclipse.
He's trying to say that the red line represents the umbra of Hilbonio. However, that's entirely false. Entirely false, because the umbra would not move in relation to the Earth. The umbra would move in relation to Hilbonio in the casting direction of the sun. According to his display here, that umbra was actually moving as if sunlight was coming to the Earth from all directions, which is not the case.
There is no way in a heliocentric model that we should witness it go from west to east, as we should be spinning into it, as simple heliocentric math will show us.
Now, I'm here to say that the numbers that Hillbilly came up with, yeah, that makes sense. They're correct. But then the diagram that they have there, and ignore the fact that their obstruction there looks like an egg. It's because they're performing their experiment inside of a video editor. In order to do that, they had to take the visual object and they had to stretch it so the center of the axis was right over the top of the Earth, so that when they rotated it, it remained the equal distance away from it. When you are performing these rotations at the precise angles that they're supposed to go, just like spokes on a bicycle wheel, the further away you get from the hub, the faster the velocity is of an object that's attached to the hub, which means one is moving a lot faster. While remaining at the same angle from the center of the hub, the distance is much greater. So therefore, the speed that it needs to be traveling to make one revolution is greater at the further distance. So here's what I did on my diagram. I'm using Hillbilly's math here. And I'm also going to show it to you with Hilbonio to show you the difference between the two. Hold on.
But there's also this.
Oh no, another map.
You'll notice here, that line, that just happens to coincide with the eclipse of 2017. Now, I've not drawn this based on the eclipse.
No, of course you didn't.
I drew this, and then Hillbilly came and explained about the eclipse,
Which I just showed didn't work.
and we looked at it, and it's like, yo, this is mighty close to where I've drawn this line.
So you want to say that somebody in Arizona has seen the sun directly overhead. I'd like to see that.
Oh my god!
No, wait, I got one more.
So this is telling us the protractor gives us false readings. And if we've worked out angles based on the protractor and the location of the sun directly, then we have arrived at an error.
Wait, now protractors are bad? But what about this?
You take a protractor. This is to work out the horizontal angle. You make sure it's vertical. You look at what degrees you need to get to, and you plot it correctly. You don't fudge, don't coax things. This is
Oh my god!